Alright guys, so your homework is to do this backside, but what I want you to do is I actually want you to do problems 1, 2, 3, and 4, these checkpoint problems on your own. So work it out, use the quadratic formula, simplify the radicals, reduce the fractions, okay? I want you to work it out just like we would be practicing in class. And what I'm going to do is I'm just going to put up the answers so that you can check yourself. But you have to work out the problem. So if all you have is the answers, then you're not going to get credit for this part. So it's like a little mini homework like you would do from the book, except it's just here on your notes. So let me grab a marker so I can give you the answers. Okay, so after you do all of the work, the answers for number 1 are -4 and -2. Okay, the answers for number 2 are 5/2. So that must mean that underneath the radical it should cancel out to a 0, just as a heads up, as a hint. And then the answer for number 3 would be 1 plus or minus I. So it looks like it simplifies pretty well, and there is an imaginary, so there should be a negative underneath your radical. And then the last one looks like it's pretty heavy. It's 3 plus or minus I square root of 3 all over the number 2. Okay, so it looks like that's how it simplifies. 2 is in the denominator, 3 is up front, and then it looks like this simplifies, and again, there's a negative inside of there. So, okay, so, and that's x equals. Okay, so those are the answers that you should get. The video is not going to be very long, but but your working on these problems would make your homework just a little bit longer. So try them and then check your answers with those 4, okay? Alright, so now, once you're done with that, then I want you to go now to the bottom of your page and we're going to talk about the discriminant. Alright, so the discriminant of the quadratic formula is just the part underneath the radical. And that's on the front part of your notes. That's one of the things we wrote down, but we are going to talk a little bit more about it. If the part under the radical, the b squared minus 4ac, okay, so the discriminant is b squared minus 4ac. That is the part underneath the radical, okay? So if you put this, if you plug a, b, and c in, and you get a number bigger than 0, so that means it is positive. If you get a positive number, then it has 2 real solutions. Okay, then you can square root it. It will cross the x-axis. The graph has 2 x-intercepts. It crosses the x-axis. It might not be an exact number, like an integer, but it will cross, okay? So if that number underneath the radical is positive, then you have 2 real answers, because it really crosses twice, okay? When b squared minus 4ac equals 0, so remember that 0 means that it pretty much cancels out. It has 1 real solution. So like the problem up above, number 2, there was only 1 answer because inside the radical should have been a 0. So it equals 0. And the graph has only 1 x-intercept, and in the past we've talked about how that is a double. Oh, I don't know if you can see that. Oh, let me look real quick. Let me slide it over. Okay, so that means that it is a double root. Okay, so that one place where it crosses counts for both answers. And we've definitely talked about that before. We've seen it before, so I just want to point that out one more time. And then, I don't know what there it is. Okay, so then it says when b squared minus 4a is less than 0. That means it is negative. So if you get a negative underneath your radical, remember negative in a radical means imaginary, so that means it has two imaginary solutions. Okay? And the graph has no x-intercepts. The curve is either going to be above the axis or below the axis. It actually isn't going to cross the axis. So this is going to cross the axis twice if it's positive. It's going to cross the axis once if it's 0. And it's going to not cross the axis because it's imaginary if it's a negative, because that means it's impossible. Okay? So we are just going to look at just the discriminant part and decide, well, what would the graph look like in general, okay? All right, there we go. Now I know that we're on the page, so you can see it all. Okay, so we're not going to work out the whole quadratic formula yet. We'll do that on the next video. But we are going to use just the discriminant. So for like number A, so it says find the discriminant and give the number and type of solution. So one real solution, two real solutions, or two imaginary solutions. Well, and this actually does want us to work out the quadratic formula. Let me see if we've got enough room, because I don't know if we've got enough room to work all that out. So, okay, so for A, we know that B squared would be 6 squared. So that's 6 squared minus 4 times 1 times 5. So that's 36 minus 20. So that gives us the number 16. Okay? Well, since underneath this root is a 16, that means that we have two real solutions because it's a positive number. So this is positive. So, two real solutions. So, two real. And the way we would work that out the rest of the way, we would say, okay, the opposite of B, so that's negative 6, plus or minus, we know that that's the square root of 16, because we've already worked that out, all over 2 times 1, so that's 2. Well, the square root of 16 is just 4, so negative 6 plus or minus 4 over 2. So that's negative 6 plus 4, that's negative 2 over 2, which is negative 1. And then the other answer would be negative 6 minus 4. So that would be negative 10 divided by 2, so that's negative 5, okay? So again, that's a lot to kind of squeeze into there, but it's negative 2 divided by 2 is negative 1, and, oh, am I running out of room again? I think I am. Okay, I think it's negative 1 and negative 5. Okay? Again, I'm not too worried about that. We're going to put all that together. Okay, there we go. That's not too bad. All right, so the point is, if it's positive here, it's two real solutions. So now let's look at the next one. B squared, so that's 6 squared minus 4 times 1 times 9. Okay, so that's 36 minus, and that is 36. Well, 36 minus 36 is just a 0. So since it's 0, that means that there's only one real solution. There's only one answer because that 0 makes the root go away. So let's plug in the rest. Negative 6 plus or minus the square root of 0 over 2, because it's 2 times 1. That 0 goes away, so it's just negative 6 over 2. So that one answer is negative 3. Okay? And that is a double root. So if you want to say double root, that means it only hits the graph one time. It just kind of bounces off of it. That vertex meets there. Okay? And then the last one, you can probably guess it. 6 squared minus 4 times 1 times 13. So that's 36 minus, I don't know 13 off the top of my head, but it is a negative 16. So since it's a negative number, it is, since that is, let me write negative, that means that when we square root that, it's going to be imaginary. So there are two imaginary answers. Okay, and the two imaginary answers are, let's see, the opposite of this. So that's negative 6 plus or minus, we know that's a negative 16. All over 2 times 1, so that's 2. And then this is just practicing reducing. Negative 6 plus or minus 4i. We practiced that a bunch. The square root of negative 16, square root of 16 is 4. And then the I. All over 2. And then we have done this before as well. Since each of those divides by 2, just divide it out and you get negative 3 plus or minus 2i. Divide that 2 by both of them, and it'll reduce for us, okay? So, this is when underneath the radical, the discriminant's positive, we get 2 real answers. Those are our 2 real answers. When it's 0, it cancels out, so we only get 1 real answer. And when it's negative, that means that when we do the square root, it's going to be imaginary. So I have 2 imaginary answers, the plus version and the minus version, okay? So then the next video is just going to be practicing through those just a little bit more so that you can recognize that without having to do the whole formula, just in case you don't have to do the whole formula, okay?